As we start into section 310, we're going to be talking about polynomial inequalities. And what this deals with is where is the function above the x-axis, where is it at, or touching or crossing the x-axis, and then where is it below the x-axis. So you have 5 different rules that you need to follow. The first one is that all terms go to one side, and you have to make sure that your leading coefficient is positive. All right, then you have 2 decisions to make. Based on which direction the sign is facing, you're either going to choose positive or negative. And then whether the sign has the line underneath it, you include your zeros or you do not include them. So if you have everything to one side and you have greater than 0, that would be positive, and then less than 0 would be negative. Now, you include your zeros if it says greater than or equal to 0, less than or equal to 0, and then you don't include your zeros if it is without the symbol underneath the inequality. The next thing you do is find where the actual zeros are, so that's going to tell you where it hits the x-axis, touches it, or crosses it, and then at that point we go to putting those zeros on a number line. We will use test values with a sign chart, which we'll do several examples of this, and then when you finish, you're going to say the solution is and type out your answer in interval notation. So this very first example up here is very straightforward. We are going to solve for x by subtracting 3x to both sides and then subtracting 15 on both sides. So this is going to give me a negative 5x is greater than, and then these are gone, and then 10 minus 15 is negative 5. And then right here, this very first one is just making sure that you understand that if you multiply or divide by a negative, the direction of this must change. So this says that x is less than positive 1. So we would be on a number line at 1. We don't have test values with this because it is not a polynomial, it's just linear. So this says that x is less than 1. So we go in this direction, and you write the solution is. So this is the briefest one that you're going to do on your homework, but the solution is the interval from negative infinity up to 1, and we do not include it because the symbol did not have a line underneath it. So the second example gets a little more complicated. Now the nice thing about this one is that it is already in factored form. So I noticed that everything is on one side, so that's my first step check. The leading coefficient is positive because it's out here and it's understood to be a 1, so I don't have to worry about that. The next thing I need to do is make my 2 decisions. Because this symbol says greater than 0, then I'm looking for positive numbers when we get down to our number line. This symbol also does not have a line underneath it, so this means that I do not include the zeros in my solution set. So that's where you're going to look to figure out these first 2 solutions. Now the last word I wrote right there were the word zeros, so that's what we're going to go do next, is actually calculate where the zeros are. So to find these zeros, I'm going to take my function that I have, and we're going to set it equal to 0 to figure out where the zeros are. So I have x minus 6 is equal to 0, so x is equal to 6 will be one of the zeros. And the other one, we will have x minus 3 quantity squared is equal to 0. So I would take the square root of both sides, which just leaves me with x minus 3 is equal to 0. So x is equal to 3. So this is where the graph itself hits the x-axis. All right, these are my 2 zeros. So I'm going to go down and on my number line, and I'm going to make this kind of big just so, because we've got a lot we have to write on here. Okay, we've got a 3, and then a 6 would be to the right of that. And I know I'm leaving a lot of space, but it's because what we have to do next. So I am going to choose test values. Now when I do this, what I'm doing is looking on the number line, and if I want a number to the left of 3, I could choose 2, I could choose 1, I could choose negative 45. Okay, you can choose any number that is less than 3. 0 is always going to be a great one to use. And what I'm going to do with this 0, that could be a negative 1 or negative 25, is plug it in to this expression. So I am going to be substituting 0 in where those x's are. And here's the nice part about this. I do not care what the number itself is. All I care about is what's the sign of it. So if I plug this 0 that I have down here in red, and I plug it in right there, then that's 0 minus 6. Well, 0 minus 6 is a negative number. All right, and then if I plug it in here, I have 0 minus 3, which is negative 3, but when I square that, I end up with a positive. So that means that I have numbers. The first one will make a negative and the second one will make a positive. So every single y value in that section is going to be negative. But my concern and what I'm looking for is right here, and we made the decision that we're looking for positives. So this entire section is excluded. This is not in my solution set. So we're going to do that process in the middle. So I have between 3 and 6, and you can choose any number you want. I'm going to choose 5, and I'm going to, again, substitute this in. So if I put a 5 right there, 5 minus 6 is going to give me a negative number. You can put the 1 if you want to, but you don't have to. And then if I plug a 5 in here for this x, I have 5 minus 3 is 2, and then if I square 2, I end up with a positive number. So a negative times a positive is again going to make this negative. So this section also is not in my solution set, so this is also a no. Last but not least, I want to go to the right of 6, so I'm going to use 7. I plug 7 in here, and I end up with 7 minus 6, which is positive. And then 7 minus 3 gives me a 4, and when I square any number for that matter, it's a positive. So that section gives me a positive. So this one is a positive set of y values. So this is my solution. Now, the only other thing that you have to decide is what happens at 6. And remind yourself up here that we said do not include the zeros. So this will be a parenthesis. So when you think that you are finally finished and your number line is accurate, then we say, okay, I have my solution set. So you are telling me I'm finished with this question and this is what I got. So you say the solution set is, and you give me the interval on which you have put yeses. So this has an infinity, of course, that goes out this way. So that would be the solution to that problem. This next example is another one that they've already factored it for you, so that's kind of nice of them to help you out. I do have all my terms to one side, but my problem is this. I have a negative out here that's a problem. So because this doesn't have a variable with it, I'm just going to divide that side by -2, and I'm going to divide that side by -2. So not only does it make this go away, but because I'm dividing by a negative, that sign flips directions. So I'm still going to have the x plus 10, the x minus 12, and the x plus 3. But now, instead of what I started with, it's less than or equal to 0. So now I'm ready to make my two decisions. This symbol says less than 0, so I'm looking for negative numbers on my number line. It also has the line underneath it, which means that I do include the zeros. So I'll have brackets at those 0 values once we find them and determine which sections work. So the next thing I'm going to do is go figure out where my zeros are. So I'm going to have x plus 10 as one of my factors. I have x minus 12 as one of my factors, and x plus 3 is one of my factors. So if I'm setting those equal to 0, that'll tell me where it hits the x-axis. So I have x plus 10 as 0, so that tells me that x has a 0 when it is -10. I have x minus 12 as 0, so I have another place where it hits the x-axis at positive 12. And then I have x plus 3 is equal to 0, so it has a third one when x is equal to -3. So at this point, I'm ready to draw my number line. So on this number line, you want to make sure you put these numbers in numeric order. If you need to put a 0 on the number line to make sure you get them in order, it's imperative that they go where they're supposed to go, or you cannot get to where you need to go with them. So a -10 is the smallest of the numbers, and then I have a -3, and then way up here we have a positive 12. So I am taking test values in each of these sections. So to the left of -10, I'm going to use -11. And where I'm putting this is into these factored forms. And again, I don't really care what the numbers are. Don't waste time doing the actual numeric expression. At that point, you just need to fill it in. So if I have -11 plus 10, that's going to give me a negative number. In the middle one, I have negative 11 minus 12 more. That's also a negative number. And then if I have negative 11 plus 3, that is also a negative number. So a negative times a negative makes positive. And then I also have this third negative here. So if I have 3 negatives, then that whole set has y values that are negatives, which means they're below the x-axis. So we are looking up here for negative numbers from here, from this decision. So this whole set is a yes. So this one is in my solution set. And you can shape that as you go, or you can wait till at the end. It's up to you. All right, I need another test value between negative 10 and negative 3. I'm going to choose negative 5. If I plug that in here, I've got 10 minus 5. Well, that's a positive number. If I plug it in here, I have negative 5 plus, minus 12 more, so that's a negative. And then if I plug a negative in here, I've got negative 5 plus 3, so that's a negative. So this is a positive times a negative, so that whole section is positive, meaning it is above the x-axis. So that one is, of course, not this negative that we wanted up here. So that one is not in my solution set. So we keep going. So between negative 3 and 12, 0 is a great option. And I'm plugging these in up here at these underlined x's here, here, and here. So 0 plus 10 is positive, 0 minus 12 is negative, and 0 plus 3 is positive. So I have that odd negative out, so that is a negative. So this one will be a yes, so that my solution does include that section of values. And last but not least, we go bigger than 12, so let's do 13, and we're plugging these in up there in the underlined x's. So in these underlined x's, we will have 13 plus 10 is positive, 13 minus 12 is also positive, and 13 plus 3 is also positive. So obviously that one is a positive set, and because we want the negative sets, this one is not in my solution set. The last decision that has to be made is what happens at negative 10, negative 3, and positive 12. And right here, we said that we do include our zeros. So we need a bracket right here, and we need 2 brackets, one on each end of this shaded area. So we have finished this problem. So you're going to tell me the solution set is. And I'm looking at the sections where I have the shaded region. So the solution set is, it goes from negative infinity up to and including negative 10, union, then I have negative 3 up to 12, and again I include those. The next one looks a little different because they have not started the process for you. So the first thing we're going to have to do is to get everything to one side. So j squared plus 2j, and then we will be adding 7, and this is greater than 0. Now at this point, what I'm trying to do is figure out if this function is factorable. So 7 only has factors of 7 and 1, and those are never going to add up to give me a 2. So I cannot go ahead and factor this, as the others have already been in that format. So I can't factor it, but we still are going to have to go find the zeros. So we'll do that momentarily. Next thing we need to do is make our 2 decisions. So this says that my function is greater than 0, so I'm going to be looking for positives. And I'm also not, we do not include our zeros because it does not have the line under there. So do not include zeros. So the next thing we're going to have to do is go find out where the zeros are. All right, now the others have been fairly easy because they've been factored. This, however, is not factored, so, and it can't be factored. So we are going to have to use the quadratic formula. So we have j is equal to negative 2 plus or minus the square root. If I square if I square 2, I get 4, and then I have minus 4, and then a times c is 7. And then I have 2 times a is 2. Now, as we work this out, we end up with 4 minus 28, which is negative 24, divided by 2. So what happens is, I don't have to continue working on this problem, all right, because we have this negative underneath here. This means that I have imaginary zeros, all right, imaginary zeros. mean the function does not intersect the x-axis. Now, what we know from working with these parent graphs is that if this one is not going to hit the x-axis, all right, I know that its leading coefficient is positive and it's squared. So I don't really care where the y-axis is. That part doesn't really matter to me. All I know is that as I graph this thing, it is all going to be above the x-axis. Now, again, I'm going to erase this y-axis because I don't know exactly where it hits it, and I don't need to determine that. So I'm just going to erase that, and we're going to look at the fact that this is the x-axis. And if this function never hits the x-axis, and I need positive y values, well, that's the entire graph, okay? The entire parabola has y values that are positive. So this means that the solution set is from negative infinity to positive infinity. Now, when you get to this question on your homework, it may or may not be all real solutions, okay, all real numbers. Yours might be something that says less than 0. So if this was the exact same thing and I flip that sign around, then what happens then is that I have no solution because there's not a single y value that this thing has that will be below the x-axis. So you have to be very careful. Look at what the diagram would be if you end up with imaginary zeros. The next one, we have to get everything to one side. So I have adding 18s squared, and I'm going to subtract 80s, and this is less than or equal to 0. And I'm looking through these, and I'm saying, okay, this leading coefficient being negative is a problem. I have to get rid of that. So what I'm going to do is just divide everything by -1. To get rid of that. And what that's going to do is flip this sign around. You cannot forget to flip the sign. It also changes the sign on each one of my terms. So I have that it's greater than or equal to 0. Now, we're going to factor this. It has a GCF of s, and then I'm left with s squared minus 18s plus 80. Still greater than or equal to 0. And then I'm looking for factors of 80 that add up to give me a -18. So those would be a -8 and also a -10. So we have our factored form. Everything's on one side and the leading coefficient is positive. So now we're ready to make our two decisions. So this says that the function is greater than 0. So I'm looking for positive answers on my number line once we get down there. This indicates that we have it that it's greater than or equal to 0, so we include our zeros. Now, once we include our zeros, then we have to actually go figure out where they are. So as we go do these zeros, I'm going to have the first term is equal to 0, so that is a 0. I have s minus 8 is equal to 0, so s is equal to 8. And I also have that s minus 10 is equal to 0, so s is equal to 10. These are my 3 zeros that go on my number line. So again, making sure that you put these in order. I'm going to have a 0, and then we've got 8, and then up here we're going to have the number 10. So now we're up to the point where we need to choose a test value in each section, and once I do this, I'm going to be plugging this into this expression, and I only care about the signs, not the actual numbers. So a test value to the left of 0 might be -1. And you can't forget to plug it into this first s. So that's going to be a negative here. If I plug it in here, that's also a negative. And then if I plug it in here, that one's also a negative. So a negative times a negative times a negative makes it negative. But we, in our search for this answer, are looking for the positives. So this one is, in fact, not in our solution set. This is a no. So then we go back and we are going between 0 and 8. So I can choose any number I want. I'm going to choose the number 2. All right, if I plug that into the first, that's a positive 2. 2 minus 8 is negative, and 2 minus 10 is also negative. So once I multiply a positive times a negative, that makes a positive. So this one is included in my solution set. So this little section is included. Then I'm going to choose a test value between 8 and 10. So I'm going to choose 9. So I plug it into the first S, so that's a positive 9. 9 minus 8 is also positive, but 9 minus 10 is negative. So that section ends up being a result of a negative, which means they're below the x-axis, which is not what I'm looking for. And last but not least, we go to the right of 10, so I'll have 11. So I plug that in, and it makes a positive in all 3 of the factors up there. So this one is positive, and this one is included in my solution set. The only other thing that we have to figure out is that we said that we have to include our zeros. So I include this, I include this, and I include this. So we have worked through our problem, and we are now to the point where we can say the solution set is. And you always want to write these from left to right. So I start at a 0 to 8, and you include both. And then we union because we have more of an answer that starts at 10 and goes on for infinity. The last set, I think you've got 2 or 3 of these questions. They ask about the domain of a radical that has a quadratic underneath it. And I want to remind you that if you have the function f of x is equal to the square root of g of x, then you know that since this is an even index, that g of x is going to have to be greater than or equal to 0. Well, in our case, g of x, what's underneath this radical is, of course, this expression. So we have 2x squared minus 3x minus 35, and that has to be greater than or equal to 0. Now, everything is already at one side, and the leading coefficient is positive, so now we need to factor this, and it will, in fact, factor. You can either slide and divide, you can use the 4 terms, use whatever method you want. If you need help with this, come see me. All right, this is going to factor into x minus 5 times 2x plus 7, and that has to be greater than or equal to 0. So now I'm ready to make my 2 decisions. So my first decision is that this is greater than 0, so this is positive. And because it has the line underneath, we include our zeros. So we have to go find our zeros. So we have x minus 5 is equal to 0, so x is equal to 5. And we have 2x plus 7 is equal to 0. So x is equal to negative 7 halves. And we are ready to put this on the number line. Make sure that you put these in order. It is very easy to put them in the order that you've written them to figure out what they are instead of the way they should be on the number line, so be careful with that. And now we are ready to choose test values that we are going to plug in to this expression right here. Again, don't really care what the numbers are. I just need to know whether the signs are positive or negative. So negative 7 halves is the same thing as negative 3 1/2. So I'm going to choose a negative 5. I'm going to plug negative 5 in right here. So negative 5 minus 5 would be a negative. And then if I plug a negative 5 in there, I get negative 10 plus 7, which is also negative. Excuse me. So that whole section is positive. So this is included in the domain. All right, now if we're going between a negative and a positive, 0 is always a good one to use. And again, I'm plugging it in. 0 minus 5 would be a negative. 2 times 0 plus 7 would be a positive. So that whole section is negative. So we are looking for the positive numbers. So this one is a no. That one's not in our solution set or our domain in this case. Now we're going to go to the right of 5. So that's going to be a 6. I'm plugging it in here for this x. 6 minus 5 would give me a positive number. And then 2 times 6 is 12, plus 7 more is also positive. So that whole section would be positive, and this is a yes, so this is included, and it goes off to infinity. Now, this said to include our zeros, so we will have brackets here and here. So we have finished this problem, and it doesn't say what's the solution set, it asks what the domain was. So the domain goes from negative infinity up to negative 7/2, and you include negative 7/2, and then you union it because the other end, 5 to infinity, is also in the domain of this function. See me with questions.